All right, welcome everyone to a new episode of the Roscoe's Wetsuit Podcast. I'm your host, Toby Passman. On the show with me today, I have a special guest, Wilf Nelson. Wilf is a PhD researcher at the Center for Human Brain Health and the owner of Mythos Media Productions. He's doing his PhD in multi-system regulation mechanics with Dr. Stephen Mayhew. They focus on how the brain regulates activation and inhibition across the cortex, with their current studies looking into single versus dual sensory stimulation. Wilf also runs a really cool neuroscience podcast called Water Cooler Neuroscience, which we're going to talk about today. So Wilf, welcome to the show.
Hi.
So tell me, I kind of want to start off with the podcast. Tell me what, you've got a really cool neuroscience podcast that I think is kind of unique in the sense that it really helps kind of flesh out these concepts that could be kind of complicated neuroscience things, but it helps kind of flesh them out where kind of your average sort of listener is going to be able to sort of actually understand what's going on a little bit. So tell me what got you into doing the podcast?
So I have been talking about the sciences since 2013. I was part of an entrepreneurial business group, which makes sense considering I've run businesses for a while. And I was brought in as the psychologist back when I was a psychology undergrad. And I would talk about how you do business and how it links. And there's a lot of stuff about how psychology can inform business if anybody's interested, but that's not what we're talking about today. And I would go and do these talks, and then I would do more talks, and I did some consulting after I finished my undergrad. And then I did some stuff where I went to like schools, and I was also on a come and see our university. So I would talk about some of the cool stuff we did. And from all of that, eventually I retrained. I stopped. So being a psychologist and being a neuroscientist are actually different jobs. And I retrained to become a neuroscientist. And when I was learning to be a neuroscientist, I saw how complicated it is because my supervisor, Dr. Mayhew, is a physicist. So he taught me the physics of the machine, the mathematics of the machines that we use. That was really, really hard for somebody who came from a philosophy and English literature background and became a psychologist to learning hardcore, not real space physics. Like I had to learn signal space and K-space and mathematical interpretations of signals, really hard. And I realized that when I was listening to the shows, and everybody who likes psychology will know this is what's going to happen. You see a headline and they'll say, tomatoes cure Alzheimer's, or this new gene we found makes you 5 times smarter. And you're thinking, okay, that's insane, but cool, I'll read it. And then what it turns out is when you actually drill into it, there's a set of Alzheimer's cells, so amyloid B plaques were one of the things that cause Alzheimer's, and tau tangles are this really dangerous part of Alzheimer's. It's really hard to cure. And an extracted enzyme from a tomato treating these cells in a petri dish showed some remission. So going and eating a whole bunch of tomatoes isn't going to stop you ever getting Alzheimer's. It's a really specific neuroscience statement. And with the one I said about being smarter, maybe taking a drug made rats 5 times faster at learning a memory task over a month. We just watch until they can't get any better. And these rats taking this drug learned it 5 times faster. But also if you gave them amphetamines, they just, physically speed you up. You would also get them to work 5 times faster. Now, I go from 2 very flashy headlines to 2 very sensible studies that you could entirely believe. And what my show does is effectively unpack how that happens. We don't always talk about headlines, but we talk about the studies that our guests do in a way that you can understand, and we break down the science the same way that it had to be broken down for me when I started, so it's accessible. Because neuroscience is not accessible. It's a very hard subject, and that's unfair. Whoever's listening to this, it is not your fault you can't understand neuroscience. It's my fault that I can't explain it to you well enough.
Well, what you're pointing out there, I think it's a difficult job to translate, kind of the hard science into something that a layperson is going to be able to understand. Was that
with time?
With time, I was going to ask, did it take you kind of a while to develop that ability?
Oh yeah, practice. But also, I've told this elsewhere, so I apologize it's not exclusive to your show, but I did talks where I would break down some cool topics about neuroscience, and I can talk about those later if you'd like. They are still interesting. And I'd be given originally an hour. You know, people come into an auditorium and I would talk and we'd explain some of the stuff. And it was really just to give them a flavor of, do you want to learn in this field? Do you want to learn about psychology? And I did that talk, and then I was like, okay, but can you boil it down to 50? You know, we've got to get them somewhere else. We want to pack more talks in. Can you boil it down to 40? And talking about what I do for research is hard, because the stuff that I do with Dr. Mayhew and Dr. Mazahiri, who are my supervisors, is foundational, just fundamental cells neuroscience. Getting you to understand it, I can do that, but I need you to give me time to explain the background that lets me do my work. I can't just jump in and give you the super fancy, flashy titles and expect you to understand anything I'm saying. I need you to give me time. And I can do that. And the hard part actually is making it interesting, because also you can't blame me for boring you if I'm being boring. And hopefully my show is interesting so you actually like hearing it, so you take it in and you can learn. When I was doing these talks, I was getting it taken away, so I couldn't give the background. And then we had people leave who were confused, and it wasn't their fault, it was mine. So I made the show because I have the time, and I only need half an hour, 40 minutes. But when you're getting that stripped down to 20 minutes or even 10 minutes, there's nothing you can do. There's no short version of neuroscience I can give you, but it's really cool. So I hope that you actually want to listen to the half an hour version.
Great. Tell me about the guests. How do you go about selecting guests? Are they people kind of involved in your research, or are there people that you just reach out to? And then why do you feel like, you know, someone's going to make for a good guest? Is there a specific topic you want to talk about, and then you end up getting a guest like from that specific area?
Okay, so all of the seasons that we've done have been sponsored. So normally when a season is sponsored, we have a rough remit that we have to meet. So the first one was with the University of Birmingham, where I am, and they sponsored for me to look into the work they did. And the second one was generally on more advanced concepts. And that sounds like a weird way to set up a series, but we took the stuff that was in season one and we effectively found more complex versions of it to try and break down for our listeners and show a more advanced state of the field. When we did season 3, we did the biochemistry of neuroscience, which is quite a unseen version of neuroscience. A lot of people see the MRIs and little pictures of the brains. You don't really see as much about how cells are treated. So we did a whole series on that. So first off, that's the remit. I can't go get a guest that doesn't do something that fits. After that, I tend to look at where I'm looking, and big names will be the first one. But that doesn't mean I'm just going to go get big names. I'm looking at the research they're doing. I'm looking at the topics that are being discussed. Then I'm looking for any papers that came out recently, you know, really active researchers are doing something. Because I've researched and gone in looking for somebody, thought their work was really cool. They've left academia, they've left a university post and they've gone to do something else. Can't really get hold of them anymore and talk about it, because the end of my shows, for those who don't know, we talk about literally what you're doing in the lab right now. So if somebody's gone off to work at an insurance firm or a bank, which many PhDs do, because those technical skills translate, I can't really finish my show in the normal way for my guests, which is what the guests want and the audience want. Then I'll normally email out quite a few people that I'm interested in having a chat with. They get back to me, we discuss, and we just kind of pare down from there. And normally what I'll try and do is then flesh out topics, make sure that we have a good range, because we know that not everybody wants to hear about the same topic over and over again. We try to give a set of variety, and with editorial control, if I think something's interesting, I'll normally then interview not that same person twice, but I'll then interview a colleague of theirs or a PhD student or a mentor, somewhere around their field that knows what they're working, and we'll do a double bill.
Right on. And I checked out a couple of the episodes that I believe it was how the series of how neurons, how neurons use energy. And I really enjoyed those. Yeah.
So that was the beginning of season 3.
Yeah. So I was just curious, you know, those definitely stood out to me. Any episodes particular that you found really fascinating to speak with the guest?
Yeah, so I did one with Gary when I did. Oh no, so one that really stuck with me was the one that we did on psychosis. So we did a double part on psychosis, and the first part we did human studies, and listening to how modern day mental health is dealt with was a very affirming and positive experience. They had this example of, I provided the example to our guest, and he went into, what if we had a psychotic patient, because we were talking about psychosis and schizophrenia, they are slightly different. And he was breaking down, what if we had a patient who thought they could see the future? Now, the Hollywood version you get is that person's going to get wheeled in, and this psychiatrist, who is probably going to be male, is just going to break you down. They're just going to push and push and push and prove you are wrong until you snap and can't accept it, and then cart you off for some nurse to take care of you while your world collapses. And that's apparently not what they do. What they do is they talk to you about, why is it important that you can tell the future? Why is your psychosis, which is how the doctor views it, why is that you need to? What happened in your life that you feel the need to talk about the world in this way? You need to see the world in this way. And we're not even trying to cure you. We just want to see what happened so we can help. Providing antipsychotics, providing antidepressives and other drugs that help the patient to see and think more clearly, because there is psychosis is not always a new way of seeing the world. It's actually a disorder that takes a lot away from a person. There's a lot of negative symptoms, and by negative symptoms, they mean you lose things to it. By helping to treat those, you help the patient to see clearer, and then you can talk about what happened and why they need help, or to make sure that they can have plans so they feel secure. And also about integrating people, which has been done really well in my country, in the UK, integrating people back into society, because it's so horrible being excluded from society. So that was an amazing episode to do. I got to see a really affirming view that modern mental health is actually, while not a positive experience to go through, the treatment that you will get, at least from the experience I had with this interview, was very helpful. And it's something I was really excited to learn about. What other ones were interesting? So we also did episodes. I did an episode with Joseph Galea, who told me about how he got mugged when he was working as a postdoc in America, which he was so flippant about. It was very funny. He was just saying, yeah, I went to go and I got mugged, and you just get held at gunpoint. And why he was okay with that. So that stuck in my mind. He did really cool. He does really interesting work on how your brain handles predicting and reward and control. But we did an episode on stroke rehabilitation. We spoke about the ways in which, if you do have a stroke or somebody you know has a stroke, how constant therapy and treatment can help to repair strokes, and the distance between current medical treatment and the research medical treatment. He was really engaged about what we know in the lab really doesn't always translate to what is in medical practice, and talking about how that can be helped. That was actually a theme over probably the last 3 or 4 months. Many of my guests brought up that just because we're talking about this in an episode, because we're talking about it in a research setting, does not mean that when you get hurt or you need these services, you're going to see the same research. But it's coming, and trying to work on that.
That's something I find really interesting. I forgot where I heard this, but someone basically, was kind of saying that, what's going on now in research labs might take, a full 20 years before it gets fully translated into whatever, pharmaceuticals or, whatever sort of treatment that comes out of it. I'm curious.
Maybe you heard it from Professor Ryan Darcy on my show, because he said that.
That's interesting. That's possible. I don't think I watched that episode, but
that's a cool episode. He's both a neuroscience professor and a CEO of a company.
Okay. I'm definitely going to check that one out. So I'm curious on what are some of the things that were brought up as far as ways to kind of fix that problem of the length of time to get translated?
Ultimately, the answer is that you do what Ryan does, so Ryan is the last episode we released. If anybody's curious, I am taking a small hiatus to finish my PhD, but I promise there are episodes coming. But what he spoke about was, rather than just decry, the big pharma companies aren't taking research, the man isn't, the NHS aren't listening, etc. Those aren't useful. One, the big companies aren't listening to you because they listen to focus groups. So you need to get on the focus groups, and you need to get on the lobbying that they actually listen to. And second, because there is a lot of research. There's a lot of research, and not all of it easily translates to medicine. So how do you know which study you take and which study you don't? What Ryan does as part of what he discussed is that he started a medical company. And then in their labs, they translate the research to their clinics and then send it out to the greater world. So I guess one of the things you can do is start pushing for labs and clinics that are near researchers. Close the divide. So rather than being, say that you have my screen for anybody who's watching this on YouTube, and for anybody who's not, in the top right, that's where your university is, and in the bottom right, that's where your hospital is. You can actually flip that for the city of Birmingham, where I currently live. Well, you say, we need to get them closer. Well, they're a whole city apart, and they've got jobs. They turn up at 9, they work flat out, they leave at 5. They're not really traveling back and forth across their city to go talk with each other and share ideas. You bring them together, you have that collision that they're meeting each other in the hallway, they're sharing lunch together. You're going to start having more ideas. It sounds really simple, but it apparently works, and science can't really argue with what works. But on the other side, patience, unfortunately. And I know that's difficult when you have a loved one or somebody you care about who is going through a disorder that is being researched, but it's a big process. And trust me, medicine that is made properly is a lot better than medicine that is rushed and not made properly.
Are you, by any chance, interested in any of the sort of applied neuroscience stuff? Like I'm thinking like nootropics, neurofeedback, neurostimulation. Is that something that you dig into at all?
I'm not. I do
Not at
really.
all.
We do really basic. It sounds basic, but we work on how your cells and your regions of your brain automatically interact and inhibit and control each other for the seamless cognitive function that we all live with. My research does not have applied focus. I've spoken in other talks about applied psychology, and I know some bits, but it's not what I do day to day.
Okay. But you do have some like personal interest in it?
Not really. Personally, I am far more interested in making sure that we understand the brain and how it works, which is an enormously complicated task, before we try and map it to the outside world. Now, I know that that's not the easiest technique. That would mean we wait 10, 20,000 years to unlock every secret of the brain, and I know we don't have that long. So other people do applied psychology, but personally, I'm much more interested in solving the puzzle of the brain and understanding it before we try and apply every aspect of it, because the brain is tricky and difficult, and it's not always the easiest thing to map. So every time I see applied approach that didn't go well, or an applied approach that didn't achieve the goals that it wanted, my instinct is immediately to go back to foundational research and try to understand the system more. And there's plenty we still don't know about the brain. But right. Obviously, doctors and nurses, researchers, engineers who are working with the brain, I'm not decrying their work. I'm just saying it's not what I do in my day.
Absolutely. Makes sense. What can you tell me about what's going on with like virtual reality and neuroscience work right now?
So 2 parts. So for our audience, we had an offline conversation where I said that I'd spoken about this stuff, and I will get to that in a second, but there is some really cool work being done in AR, which is augmented reality, where you see a screen and things are plastered. Like Pokemon Go is a perfect example. I know that's a bit pop culture, but it's a really good example of augmented reality, a glass screen that provides you additional information on the world. Virtual reality is a replacement to your environment. And we are doing some really cool work. There's work done at my labs. I've been a guinea pig for some of it, but I don't do it, where we can test you in environments to try and see how you move. We can test you in environments to see how you handle additional information, conflicting information. And these are done with different headsets in big rooms. And it means we can also test pretty interesting stuff. So say that we put you in a virtual reality, we can suddenly, there's papers I'm having to read for my thesis where they flip the entire presentation and swing you around. Basically, you teleport. You don't really teleport, it's only the screen teleports. And what happens is you're suddenly from one side of a mountain range to another side of the mountain range. And that quick, sudden change in perspective means we can trick the brain into having to go through some pretty intensive processes. That gives us a lot of information about how the brain handles perspective and memory. And it's stuff you can't do naturally because you can't teleport people across mountain ranges just yet. Physicists, please get quicker at making that work. So AR and VR is very interesting. What I spoke about was more about a cautionary limitation and not getting overexcited about AR and VR in the way that it's being marketed. So, small story. Some companies, you can look at which ones they are offering that you will be able to upload your brain into a virtual world. And some have even claimed as close as 2035 and 45. The tales that I spoke of were that even if you could upload your brain and make a perfect world for your brain to inhabit, there's a problem. And this is what we speak about a bit on my show, which is science has limitations. We don't know everything yet. So let's take an example. We'll work on my research. The research that we do, your brain doesn't always want all of your senses to be at maximum power all the time. Sometimes it wants to turn them down when they're not relevant. For example, me and my illustrious host right here and yourselves will not really be thinking about how our feet are working. You certainly will now because I mentioned it, but beforehand you probably weren't feeling that much from your feet because it wasn't relevant. That part of your brain that handles that for you will actually have had a reduced signal. Sometimes we call them inhibition signals. We don't know perfectly how that works, and I know we don't because that's what my PhD is on. So we put you in the virtual world and we can't model that perfectly, and we can't model it perfectly because we don't know how it works yet, not that we can't code it. Then how do we make it work in the virtual world? It's a really obvious problem. And we're not going to solve all of neuroscience in 20 to 30 years. We just aren't. I really would like us to, because it would give me some really cool stuff to talk about, but we aren't. So when people are saying we're going to upload you into a virtual world and physically put you in there so you can walk around, you need to ask, can we understand the brain well enough to recreate all of it? It's not an issue of programming power or processing power. It's an issue of, do we understand every single system and how they interact to be able to even code it? And arguably, there are some things that don't code. A human being's love of literature isn't an easily codable thing to do. Machines don't really understand, and trying to code that into ones and zeros and if and then and while clauses just doesn't map. So the talk I did effectively said, if there is some great machine that would load you up into the new world 2.0, perhaps be a bit more read up about what neuroscience currently understands about the brain, because that will be the limit of what we can code for you. The reason this is important, and this is very important, is consciousness. I know that when you see like The Matrix and you see other sci-fi movies, consciousness is this weird ethereal thing that you just pour out of brains and pour into other brains. So I could take my consciousness and pour it through the internet and it would appear in a person. It could appear in my lovely host's mind and I would be him and I would speak and continue this sentence with his voice, and then I would flip back over to mine and I would have been a zombie for a couple of minutes. It doesn't work like that. We don't know what consciousness is. Nobody has a proper theory about what consciousness is. The only thing we think we could possibly do is make patterns to replicate it. But that means that it is copy paste. It is not cut and paste. We can't take you and brain you and put you in a machine. We would copy what we think are the patterns that are you and place it in a machine. That means there's two of you. That's really important. And more importantly, that virtual you is now in a virtual world and exists in a virtual way. So they can't get ported back into you because you're already in your head. So if this world's incorrect, because we can't code it fully, you're trapped in there. There's no other place to go. And that's something that I've warned cautiously about. I'm not saying that when virtual reality is made to be scared of it. I'm saying to do proper research and understand what is being offered. Because if it's poorly made and they put people in it, you are stuck. That really is a terrifying prospect. So this is what I spoke about the limitations of neuroscience, about understanding with researchers where we are in the field, what we do and do not know, and being able to realize that this is what we have. It might not be what you want, but it's still pretty interesting all the same.
Do you have similar skepticism about, I don't know if you're at all aware of like what Elon Musk is trying to do with Neurolink?
I would
As far
love to
as
know more about Neuralink when he publishes papers. I've had a look at Neuralink. I even actually, when I was looking for jobs, I even looked if they were hiring, and there isn't any published work, so I don't understand what they do. But Neuralink is going to hit this problem, the same problem I'm talking about, and it's not Neuralink are really clever, you don't understand what Elon Musk are doing. If I can't tell you, and my supervisor and the people we work with, whole world experts in how the brain handles, how your systems in your brain regulate and interact with each other, if we can't tell you everything your brain is doing second by second, and we are the people who study this for a job, then how can they? And it's not that they're stupid. The information doesn't exist. We've not finished the research. So no matter how good their system is, if we don't know, we don't know. That's just a fundamental limitation. It's like saying that, you know, the Wright brothers couldn't have made their plane before internal combustion. It's like, obviously, it's not the Wright brothers are stupid. Before an internal combustion engine, planes didn't work. There are just technological and intellectual limitations on our time. And they will be fixed. There will be very clever people who will do it. But we don't have it right now. And one of the things that my research, my thesis has done is we took a base theory that's very famous and it understands how your senses interact with each other. It's a very useful theory. And we extrapolated it to new circumstances, new situations, and new systems in the brain. None of them responded in the same way. Taking a really easy, cut and dry approach of going, well, we have this one theory, and in theory, you know, when scientists in sci-fi movies go, in theory, it makes sense, it should work. Theory means nothing. Testing, data, lab work, that's what matters. And when we took a theory that we thought would move to different situations, every single time those systems worked in new and different ways because they're under no obligation to work in ways that make sense. They work in their own ways. And that it makes, when we've actually researched it and looked into it more, it makes more sense. We understand the system better. But you can't be lazy. You can't just say, we have half the knowledge, logically the other half works in the same way, let's get going. So I really am actually excited to see Neuralink and virtual worlds. I'm a massive fan of the books like Neuromancer. I think Neuromancer is one of the great sci-fi books ever. But just because I really like it doesn't mean I think we're there yet.
Okay.
And also, if Elon Musk would like to reach out and come on my show and tell me how I'm wrong, please tell me how I'm wrong. I will have a lovely conversation. I'm British. Our manners are perfect. I know, living up to stereotypes, but let's have a chat.
Well, I'm assuming Elon is watching this, so you know,
of course he
you
is.
know what to do. Yeah.
You say Elon Musk's name on the internet and he finds you.
I don't doubt that. So with kind of your own research, along with being able to talk to all of these top experts in just the whole field of neuroscience, what are some of the most kind of important, like, basic principles that you feel like people need to understand about how their brains work?
Okay, so let's have a think. Really important concept about how your brain works. First off, don't try and hack your brain too much. And I'm not saying you're going to break your brain or anything. Your brain will take care of itself. It just will. So I'm going to give you some basic neurohacking tips, and you're going to get annoyed at me because you're going to know them all. 1, drink water. Just drink water. Don't drink fizzy drinks, drink water. 2, eat good meals. Don't eat fast food. It's good for you. Try and cook your own food if you can. If you can't, make sure you eat healthy foods. 3rd, get a bunch of sleep. 4th, exercise. Katrine Sagard did a really good episode about how exercising makes sure that your brain declines slower, because there is something called healthy aging. You do lose cognitive function as you get older, but you can help that and not be so severe by doing exercise. These things are just normal ways to make sure your brain is healthy. And the better your cardiovascular system is, the more blood and oxygen get to your brain, and the healthier your brain will be. The more you hydrate the brain, the less trouble you'll have. The more you eat good foods. Your brain is actually mostly made out of fats and salts, weirdly, I know, and some electrolytes. But if you get them from good places, you know, good fats, not fats from eating fast food, you get, you don't like have really bad sugars and salts, but you have a good, healthy diet, these will be better. And I know that sounds really boring, but I promise you don't need to eat like 27 grams of kale or try and get into ketosis or whatever. It's not going to suddenly make you smarter. you're fine. And I say this because I want to save you money. You know, when I see things like have 2 teaspoons of coconut oil and rub some, you know, polar bear glands on your wrist, and this like hacks your brain. Maybe. Show me a study. If you can show me a study or a replicated set of studies, I can't argue. That's science. But in the meantime, just save yourself some cash and drink a glass of water and go for a run. Annoying point number 2, and these are annoying, I'm sorry, is annoying point number 2. You aren't going to change that much in a short period of time. One of the things that I learned as a psychologist is the brain is a system. It works in regular and repeatable ways. We are creatures of habit. So if something is occurring repeatedly, you're not going to really change that without a huge amount of effort. And let me give an example. Say that you want to study for your exams, or you're studying for a professional accreditation if you're outside of university, and you have 3 months, and you are terrible at revising. So you say, okay, I'm going to set up a schedule. I'm going to revise every other day for half an hour and really kick that revision in. You're like, cool. And then you don't revise at all for a whole month. And then you go, okay, well, I've got to revise every single day now because I've only got 2 months late. And you're like, okay, dodgy maths, but fine. Okay, and then you're like, then you don't revise at all. And you're like, now what I'm going to do is I'm going to revise for an hour every single day. And really, it's like, for the last 2 months, you've shown evidence that the system is you're not revising. You need to find a way to not just keep doing the same behaviors over and over again. It's not failure. You just need to adapt. And if something is not working, you change. Or if you come up against a system where you know other people are going to behave in a certain way, it's going to be difficult. Don't just bang your head and complain and say, well, it shouldn't work this way. You need to try and find different ways to handle the situation. Now, obviously, when you're dealing with mass institutional problems across the world, that's not what I'm talking about. But, you know, when you're trying to get a new promotion or you're trying to get some work you have seen, if you know that something's not going to work, don't repeat it. Find a new way around the solution. So accept that human brains are a system, and getting them to change rapidly is not going to really happen. And the third thing I would say is reach out if you don't understand something. There are conversations I'm just not qualified to have. So I live in the UK, and our Chancellor has said that we have hard times coming because we are entering into a recession. So we're going to have budget changes and stuff. I'm a smart bloke. I do a neuroscience PhD. I run a show that talks about pretty high level concepts, but I am not qualified to talk about an economics budget, and nobody should be coming to me for advice on an economics budget. I don't have a PhD in those topics. If I want to understand those things, I'll go find an economics PhD or somebody who works in that kind of high level institutional banking. I also won't just go to somebody who's a teller at a bank. I'm sure they're a lovely person, but they don't know how you organize the finances of a country. Billions and trillions of dollars. That's a very complex system. So I have to accept that I have things I can talk about, things that I've researched and I understand, and places where I just have to eat humble pie and go talk to somebody else politely and have a conversation and let them educate me. When it comes to neuroscience, my show offers that it's not your fault you don't understand neuroscience because it's bloody hard. So I explain. When you are trying to find things out, when you're approaching the brain, when you're trying to understand your brain, it's really difficult. A lot of your brain does not work the way you think it does. I'm sorry, but it doesn't. Brains are annoying and tricky and difficult and aggravating, and they work in counterintuitive, difficult ways. That's why we need science to break them down. We put them in scenarios that they have to work in certain ways, and we watch the results and we see how it works. And quite often, how somebody behaves is completely different to how they say they're behaving, but we get to see the evidence of how they are actually behaving. So when you're trying to understand how things work, be willing to say, is there an expert? Is there a show? Or can I just pop somebody? Most lecturers love talking about their work. If you hit them up on Twitter, they will tell you loads about what they do. So rather than make the mistake with a system like, say, Twitter or Facebook, where you can say something and just hit a brick wall of people telling you, and they just say, trust me, I know, I'm smart and the government's stupid, try and hit up the experts. You know, go on the Twitter of an economics expert. There was so many people when Brexit was happening who were saying, I am an international expert in EU law. This is what it means. they were just broadcasting that out for everybody to listen to. So that's what I do. When I don't understand something, I try to learn a bit, but if it's really outside of my reach, I just go find somebody and ask. So that would be my suggestion for things to do about your brain.
Besides listening to Water Cooler Neuroscience, what are there other people, other researchers that you feel like are really good at actually translating their work into kind of practical, things that lay people can understand? Like if someone, listening to the show really wanted to find out more and understand their brain better.
Yeah, so if you want to understand more about psychology, here's a couple of things you can do. First off is just find some basic psychology textbooks. They are written for people, they're literally the year one psychology textbooks that you can go get at a library are written for people who've never done psychology before. So if you really want to learn, you can just read them. They're not massively interesting. We do some shows where we break them down for you to make them more interesting. But if you really want the knowledge, they're there. More engaging stuff out there. There is some really good stuff. My favorite is Naked Neuroscientists, although they've finished some of their work. But they did some really cool shows and they inspired me a lot. A lot of what they used to do, I've now taken that model and tried to turn it into my own. Been willing to ask the difficult questions and probe. Sam Harris is a very famous podcaster now. He was a neuroscientist. So some of his older work actually discussed a lot of neuroscience, and I hope one day to be as popular in what he did in neuroscience, although I don't have his interest in the outside world as much. So I know he became a mindfulness and political commentator. I have no interest in those worlds, although I understand they need to exist, and I do listen to him. But his neuroscience work was really good. Also, there's Oliver Sacks, who's very famous. I'll give you a piece of advice. If you want to know more about neuroscience and you want to know more about psychology, 2 tricks. Go to a library or go on Amazon or go on your bookstore or break into a family member's house who won't call the police. Go look at their bookcase and then find books on neuroscience that are or the psychology that are trying to teach you, but not trying to make you a better person. And here's the reason. If they say 10 steps to better memory, they're trying to sell you something. And if they're trying to sell you something, they're probably not going to give you the full discussion of the research. You should read those books once you understand the field a bit better, because you need to be able to know what does and does not make sense. But there are really interesting ones on consciousness. There's really interesting ones on how we understand memory. Elizabeth Loftus' work is really famous for understanding this. There's really great work on understanding how memory disorders work. The Man Who Mistook His Wife for a Hat is a really great book about understanding a man called HM who lost his hippocampus, most famous psychology case in the world. Those ones, they'll fill you in. They will give you more information. Now, I'm not going to lie, you will never be as read as somebody who spent 3 years doing a full-time psychology degree, because they spent 3 years doing a full-time psychology degree. They're going to know more, but you will be read. And I like reading about physics and history and geography and politics, but I don't go and try and get into arguments with history PhDs and say I know more, but it's cool to understand. So that would be my suggestion. These aren't hard things. Go find a podcast I mentioned and just look for anything that's trying to really teach you about the brain and read it. And then when they'll mention other people's books, and then go read those books, and then go read those books, and then spend so much money that you don't know what to do with yourself.
Right on. Yeah. Seek out the experts.
The experts are always willing to talk. Always.
Where do you see kind of Water Cooler moving towards in the future? Like, do you have any kind of grand plans?
So after my PhD, it's actually what we're doing. We're taking the company full time. So those who have wanted more episodes of me, I will now have time to make them. What we're going to be doing is looking into some series. We want to look into how consciousness is understood. So right now there was a famous statement that said, any psychologist and neuroscientist who can tell you what consciousness is lying. I entirely stand by that. Nobody knows what consciousness is. It's a really difficult concept to understand. But I want to do a series looking at how far we know and what do we know. Just because you do not have the grand answer does not mean that we don't have something of value so far. Now in 2020, we know a lot about memory, but that doesn't mean in 1980, we didn't know a lot too. We just knew less. So you don't take all those 1980 studies and just chuck them out the window and assume there was nothing there. So we don't have a concept of what consciousness is right now, but we're learning more and more interesting things about how consciousness works. Parts of the fact that we appear to be sleepwalking for a lot of our life, and parts that we seem to apparently have multiple consciousnesses in our brain, which they've been able to show. These are interesting concepts. And maybe we don't understand how they all fit together yet, but it's a cool thing I want to talk about. And that's one of the nice things about running your own show. We also want to do, there was an article by Wired calling out computational neuroscience. So the US and UK definitions of computational neuroscience are different. I'll break them down quickly. In the US, computational neuroscience is where you use computers to make models that help you understand brain data. That's a lot closer. So when you run an fMRI and you get all this data and all these images of the brain, you use a computer and you break that down into something that's readable, because machines can understand that much data. Humans just can't. It would take us decades to do all the analysis. When you are looking at computational neuroscience in the UK, that's actually where we try and get machines to model brain functions. We try and make a machine that can replicate a brain function. We're not making conscious AI. We're literally just trying to make a system that might be able to do a memory game. And all we do is we just punch in the numbers and we show a person the numbers. So first off, we're not even replicating vision, because we just punch the numbers into a machine, but we see if it can remember. That's the kind of stuff that is computational neuroscience in the UK. An article in Wired called out computational neuroscience in the UK as effectively useless. It's existed for 20 years and come up with nothing of value. It was a pretty harsh article. I'm not sure I entirely agree, but I have got questions about it. So I want to do a dive into, what does computational neuroscience know? And was that assessment unfair? On occasion in science, you can go, this field knows nothing. And their reply is, well, of course we know nothing in that because we're studying this. So on occasion, you can ask unfair questions. So that's what we're going to be looking into. And time permitting, I'm also going to be doing some more psychology on basic neuroscience and psychology. And by basic, I mean undergraduate core concepts, stuff that I have the privilege of knowing because I have a formal education in the brain, but our outside listeners who went down other paths don't. So we're going to bring it to you, which I was told apparently you don't have SWAT teams from universities bust in when you do that. I thought they might.
I guess not. Well, when it comes to kind of consciousness and then the different theories about it, at least what parts of those different theories do you think are most backed in the research? Like, are there any basic components of consciousness that you think we really do understand?
We understand that we understand that, first off, there is research showing that human beings don't have free will. I'm sorry, I know it's a really hard statement to swallow, but the neuroscience evidence says that we don't. I don't have time to go into it here. It's a really long topic and you can find other places, but how brains are reacting and preparing for information occurs before we know what we're going to do and when that consciously appears in our brain. So the conscious experience of free will, of conscious experience, is probably not entirely true from our own experience. Now, that doesn't mean I'm not saying you're you. If the back of the subconscious of your brain is making your decisions, that's still you making the decisions. But how that plays out in your head and if that feels the way it is might not be entirely true. Other things that are pretty clear is that people can on occasion react to things they haven't physically registered yet. So not making decisions, but you can jump out of your skin seeing a coat that you thought was a person before you even know what you're scared of. There are reactions in the human brain that occur below the conscious level. Apologies. Other things that are important. There's a basic concept that even the Romans spoke about. It's a really old idea. Does conscious thought and our minds get generated by our brains? You know, the squishy organic chemistry of our brains? Or does it exist in some hypothetical mental realm? You know, the mind and brain. So when people say they study the brain or the mind, you already get this dichotomy that the brain is a physical organ that doctors can treat and the mind is separate. I'm a scientist. Physical non-brain realm, so brain realms don't exist. Show me one, test it, prove it, put it in front of me, I'll believe you. I can't see quantum physics, but I believe it exists because I've read the papers and I know it exists. So if you can prove to me a mind realm exists, go ahead. But for now, our brains and physical chemistry and physics generate consciousness. I can't see a way around that. I just can't. So it's a really interesting concept, but trying to understand how the consciousness works when it is the lens, stage, world, camera, and background that you are trying to understand, the lens, stage, background, and camera, and everything through, is a ridiculous paradox. You can't step outside consciousness. And that's a lot of what we do in science. We step outside, we test, we manipulate, we understand. With consciousness, it's very hard because we're never free of it. We are always consciously experiencing something, or we're unconscious. And then you can't study consciousness because you're unconscious.
Well said, yeah. Well, Wilf, we're coming up onto the end of the show. I really enjoyed this discussion with you today. If people want to find out more about your work, your podcast, where would you direct them to?
So we have a website, which is Water Cooler, like the things in your office, neuroscience.co.uk. And that's where we have our site, we have our episodes, and you can see more about the guests. We're on all of the major podcasting apps. So I think we're on 44 in total. So if you can't find us, go on our website, scroll down the page, you'll find the email, complain at me, I'll fix it. We're also on Facebook, Reddit, Twitter. I have a personal LinkedIn if you want to get in touch for business inquiries, if you do. And
for
we can go from
Elon
there.
Musk.
Yes, Elon Musk, email me. Tell me why I'm wrong. Or actually, no. Let's not do it. No, everybody else, tweet Elon Musk and then say that he needs to get in touch to educate me. I'm not saying he's wrong. I'm saying I don't understand his work and he needs to educate me. Let's start a Twitter storm and get him to tell me how I'm wrong.
Agreed. And Elon, might as well come on Roscoe's Wetsuit while you're at it.
Yeah, can I ask, why is it Roscoe's Wetsuit?
That is a conversation that I cannot sum up very quickly, but I will tell you off air if you're really interested.
Okay. So also, let's start a Twitter storm explaining why it's called Roscoe's Wetsuit.
There we go. Perfect. Twitter storms all around.
So yeah, we're on the spot, we're on the apps. We are coming with YouTube and stuff later when this is what I do full time. Hit us up on our website. Get in touch. We'll be around. We've had people get back, and we normally get back to you in a couple of days. We try to read up and get back to everybody. And if you want to suggest an episode, why not? I mean, I can only ignore you, but I won't. I'll listen to what you say and have a conversation. But the worst I could do would be ignore you. Right
on. Well, if you guys enjoyed the show today, go ahead and like and subscribe to our YouTube channel. We're Roscoe's Wetsuit. And you can also find the audio version of the podcast available a lot of different platforms: Spotify, Apple Podcasts, iHeartRadio, Stitcher. Yeah. Probably not as many as yours, but you can definitely find us on a lot of the audio platforms.
I just went nuts one day and just uploaded up to everything.
There
yes,
you go.
You see the red bell. Do that.
Ding, ding, ding.
Or, go on Spotify and just hit both of our podcasts. It's fun. If you're listening to this, you're probably already on his podcast.
Right. Very right. Well, Wilf, again, thanks so much for your time today. Really enjoyed the conversation.
Yes. Thanks for having me on.
Absolutely.